In this example, we need to solve the equation the square root of the quantity 3x plus 1 equals the square root of the quantity 2x plus 6. Well, what type of equation do we have here? Notice there are square roots in it. It's a radical equation. But how many square roots do we have? We have 1, 2. So let's look at the steps for solving a radical equation that has 2 square roots in it. The first thing we need to do is isolate just one of the square roots. So looking at our equation here, if I look on the left, is that radical isolated? Yes. So step 1 is already done for us. Step 2 says to square both sides of the equation in order to remove the isolated radical. So I'm going to take my square root of 3x plus 1 on the left-hand side and square it. And then on the right-hand side, I have to square this square root too. So I've got the square root of 2x plus 6 all squared. Well, what do you get when you square a square root? They undo each other, and you just get left with the radicand, which is the name of the quantity underneath the square root. So on the left-hand side, I'm just going to get left with 3x plus 1. And on the right-hand side, I'm also squaring a square root. These two are going to undo each other, so I'm just going to get left with 2x plus 6. So that is step 2. Step 3 says if this equation still contains a radical, repeat steps 1 and 2. Well, do I still have a radical left in my equation? No. So that is done. Step 4 says simplify and solve the resulting equation. Well, what type of equation do we have here? What's the highest degree on any of the x's? It's a 1. It's a linear equation, so you need to collect x's on one side, numbers on the other. I think I'm going to collect my x's on the left-hand side, so I'm going to subtract 2x from both sides. And in the same step, I'm going to move this plus 1, so I'm going to subtract 1 from both sides. So on the left-hand side, I get 3x minus 2x is x. So I just get left with x because 1 minus 1 is 0. 2x minus 2x is 0, so on the right-hand side, I just get 6 minus 1, which is 5. So I have solved my resulting equation. But don't forget, you must check for extraneous solutions. What this means is that you have to put your solution of x equals 5 in the original equation and see if you land up with a true statement. So I'm going to put 5 both here and here. So I'm going to get the square root of 3 times x, which is 5, plus 1 should equal the square root of 2 times x, so it's 2 times 5 plus 6. So on the left-hand side, I have the square root of 3 times 5 is 15 plus 1 should equal the square root of 5 times 2 is 10 plus 6. So does the square root of 15 plus 1 is 16 equal the square root of 10 plus 6, which is also 16? Is that a true statement? Yes, because the square root of 16 is 4, and so does 4 equal 4? Yes. Therefore, I know that x equals 5 is a good solution to this equation.